everybody. My name is Peter Croal. I'm a geologist, and I'm here to share with you a story that is seldom heard by many people. Not too many people on this planet know what I'm going to be talking about, except for other geologists. And it's really the story of the moon and how the moon has given us life on this planet. And I want to thank Wabano for this opportunity to speak to you about this. So let us begin with just a few remarks about how people thought the moon was formed originally. Way back when, in George Darwin's time, people thought the moon was formed from the Earth spinning so fast that it flung a bunch of magma, molten rock, out into the universe, which formed the moon. Another theory is that the moon was captured by Earth. There was all this dust and debris, and the Earth brought it in to become the moon. And the third theory is that there was this leftover dust that became the moon. None of those are true. But once upon a time, there was a big bang. And I want to say that as a geologist, I'm telling a story, the story of life and the story of creation. Science is just one way of telling a story. And geology is one way of telling a story. And Jan Longboat, from her First Nation perspective, is also going to tell a story. And these stories of creation are all legitimate. The First Nation story is correct, and the science story is correct. It's a way of justifying and trying to understand who we are and why we're here. There's a First Nation perspective, which is wonderful, and there's a science perspective. And science doesn't know everything. And so we go with the information that we have when we try to create the story of how life began. So once upon a time, you've heard of the Big Bang, a massive explosion that created the universe all of a sudden. And then, shortly after that Big Bang, there was a gigantic shock wave that rippled through the brand new universe, just kind of like a tsunami of energy flowing in all directions. And what that did was, it started the very first rocks and dust that were created from the Big Bang to start to rotate. And that rotation caused the very first planets to start to form and become rocks and planets and moons and things like this. This was about 4.5 billion years ago. And when our galaxy was just starting to form, our solar system was also starting to form. And we have our sun that we see every day. It took 50 million years for that sun to be formed from the concentration of hydrogen and helium. So that's a long time before our sun became born. And for those that study the sun, it's a very average star in the universe. There's nothing very spectacular about our sun. But then, after the sun was formed, about 500 million years after the baby Earth was formed, there was all of this debris still floating around in our solar system. And a huge chunk of rock smashed into the new forming Earth. And that big chunk of rock was called Theia, according to the geologists and scientists who study this. And it's also called the Big Thwack. So this giant piece of rock blasted itself into the new Earth. And how do we know this? We know this because that's a picture of the moon right there. At the bottom of the moon, you see all that blue. That is an indication that there's very, very dense rocks there. It shows that there was a massive impact to cause those rocks to be formed on the moon. And as well, on planet Earth, we have a mineral called trinitite. And trinitite is formed, for example, at nuclear blast sites, where there's tremendous amount of energy. And trinitite is also found on the moon as well. So those are two clues to show that there was a massive explosion at one time. And the Apollo mission also proved that there was this collision because the moon rocks, when they're brought back and analyzed, do not have any nitrogen, sulfur, or carbon. They were all burned off during this massive collision. As well, this huge rock that crashed into the young Earth brought water to us. And if we don't have water, there's no life on this planet. So hydrogen and oxygen was injected into the young Earth by this collision as well. Now, what is getting really interesting about this particular collision, it was a 1 in a trillion odds of this happening. If that rock had hit Earth directly, the whole planet Earth would have been shattered. It wouldn't have existed. But what happened was, this young planet, or this young sort of gigantic meteorite that hit Earth, came at a glancing blow. So it really didn't destroy the planet, it just kind of really gave it a good shot, like a really bad car crash. And that blast injected a whole bunch of rocks into the atmosphere, which created the moon. So the moon was created from a collision from a very young planet crashing into Earth, creating the moon. So this picture here is one of the most fascinating pictures I can show you, I think, because when the moon was first formed, this is what the moon would have looked like if you were alive and looked out your window today to see where the moon was when it was first formed. And the reason I say this is because when the moon was formed, it was formed a lot closer to Earth than the Earth is from the moon today. And each year, the moon is moving 4 centimeters away from Earth. And there's reasons for that, which I'm not going to go into, but the moon continues to move away from Earth. But if we were here on the planet 4 billion years ago and looked out our window, that's how big the moon would be, because it was really close to Earth at that time. Now, here's where I have to stop and pause a little bit to talk about Thomas Alcoes, who is a Navajo gentleman from Arizona who studies biology. And he says, science is not just a white man's thing. And I want to say that because of this. Thomas King wrote Coyote Tales, and I read Coyote Tales a few weeks ago, and on the first page, I read that statement, and it says, in those days, the moon was much closer to the Earth, and the light from the moon was much brighter. That absolutely stopped me in my tracks. I could not believe what I was reading, because a First Nation man knew that the moon was moving away from Earth. Not too many people know that. How did First Nations people know that the moon was moving away from Earth, and that the moon's brightness was a lot brighter a long time ago than it was today? I find that really fantastic. So back to our story. 4.4 billion years ago, it was a chaotic time. The Earth was spinning really quickly, so a day was 5 hours instead of 24. The Earth was covered with molten magma. You couldn't see the stars because of all the gases and debris that was in the atmosphere. But now we're getting to the story of how life is formed on this planet. When that young planet, that young big rock crashed into Earth, it injected a whole bunch of iron and nickel into the center of the Earth, and a lot of water as well. So that's sort of very first thing to hang on to. A bunch of iron and nickel was injected into the center of the Earth, which became the core of the Earth. As well, that collision brought sulfur, carbon, ammonium, nitrogen, all these good things which create the soup for life on this planet. That nickel iron core that we have beneath our feet, thousands and thousands of kilometers beneath our feet, protects us from the sun's ultraviolet radiation, because that iron core creates a magnetic field, and we all know about a magnetic field from using our compasses and so on. That magnetic field protects us from ultraviolet radiation. And if we did not have that magnetic field, we wouldn't be able to survive on the planet today. No life would survive. So there's another little clue of how the moon gave us the ability to have life on this planet. That collision also gave us the very first continental rocks that form the foundation of this planet. And every home needs a foundation. So the moon brought all of these rocks to Earth to create the foundation for the continents. It also gave us very special rocks. I want to make a note of this rock called feldspar, which has all the elements of life. It has sodium, potassium, calcium, and oxygen. And feldspar, when it erodes and becomes other elements just through erosion and weathering, it becomes clay. So all the clay that you see around in your gardens and various places on the planet, a lot of that comes from feldspar. And I just want to go back to clay in a little while because it's an extremely important part of how life was formed on this planet. That collision between Earth and that small planet started the whole process of plate tectonics. You might have heard of plate tectonics, that the continents float on top of this semi-molten sea of semi-molten rock beneath our feet, and those plates move. They move all the time, and those plates are very important for the creation of weather systems and erosion and glaciers, which I'm going to talk about in a very few seconds. Now we're getting to something which is extremely important for the creation of life on this planet. That huge collision tilted Earth into 23.5 degrees. If we did not have that 23.5 degree tilt, we would not have seasons. And those seasons are extremely important for the development of life on the planet. The other thing that the moon gives us is that 23.5 degree tilt is kept in that position because the moon holds us in that position. If we did not have the moon influencing Earth with its gravitational pull, the moon wouldn't be there, the Earth would flop over, and Jupiter would become our dominant gravitational pull. So instead of being like this, we would flop over like that, and we wouldn't have seasons. So the moon keeps us stable in our orbit. So we have to put the brakes on right now, because I've talked about a lot of scientific things, and I just want to do a very quick summary of what I've said so far. There was a big bang, there was a shock wave, there was dust, and the planets started to form, our galaxy started to form, and the sun, our own star, was forming. Then there was this gigantic collision, the big thwack. This rogue, huge rock came out of nowhere and hit Earth. It was a glancing blow. It injected nickel and iron into the core of the Earth. It gave us sulfur, carbon, ammonia, oxygen, and phosphorus. It also gave us the magnetic field. It gave us plate tectonics, gave us continental rocks, gave us the seasons because the Earth is tilted. It anchored our orbit, and it gave us tides. So Grandmother Moon, Nokomis, is known for the creation of tides. And without tides moving back and forth all the time, ever since time immemorial, we would not have life. I'll talk about that in a second too. So we have all these conditions now. We have the stability of the planet. We have got all the materials that you need for creating life. How did actual life start? So the very first indication of life was the use of lightning and asteroids and UV light, all of this stuff. It was a chaotic time billions of years ago. But there was a chemical created through all this lightning and asteroid impacts and UV light called hydrogen cyanide. And that chemical was the actual soup for the creation of life. And you might have heard this too, that Earth is in a Goldilocks zone. We're not too far from the sun, not too close to it. We're just in the right temperature range, not too hot, not too cold, just like Goldilocks, to create life. You cannot have life without RNA. You've heard of RNA and DNA. RNA is important because it is the train that carries genetic material from one cell to another. And RNA was created when UV light converts cyanide to simple sugars. With all those other beautiful things that are in this life soup, you get RNA formed. And you cannot have life unless you get cells. And a cell can only exist if it has a membrane holding all of those good things inside of it. So RNA became fatty acids, which creates the membranes for cells. So we've got the first indications of life forming from RNA. We don't have life without DNA. That's the stuff of us. This is who we are as life forms. And you cannot have DNA without nitrogen, phosphorus, and magnesium, which came to us from the Big Thwack. The very first breath of life happened about 3.7 billion years ago, when what they call sticky little one-celled organisms started binding themselves together. And they bound themselves together around clay. And that's when I said a few moments ago, clay is so important, because clay is really, really fine-grained. And we've got all this fine-grained stuff floating around in the oceans and on beaches. It's a perfect platform for these sticky microbes to find a home. And they all gathered together on these clay pieces, these clay clumps, And you got the very first organism on the planet called stromatolites. They were discovered in Greenland. A stromatolite is nothing more than a small mound of bacteria that takes in carbon dioxide from the atmosphere and breathes out oxygen. So when we take a breath, we have to thank these very primitive plants, if you want to call them, that started living 3.7 million years ago. And that's what a stromatolite looks like. That is a stromatolite that exists today in Australia. So when we breathe, we are breathing oxygen that has come from these plants. And that's what the bacteria looks like. It's called blue-green algae, and it still exists today. And if you do like to breathe, and I certainly like to breathe, one of 4 breaths that we take on this planet comes from these organisms. They're called one-celled little organisms called diatoms. And they're one-celled organisms that are covered in silica, kind of like quartz. And they do not live, they cannot survive unless they have iron. And where does iron come from for these lovely creatures to form? They come from glaciers and the Sahara. As an example, if you see a glacier and it's green, it's because there's lots of iron in that ice from grinding on the bedrock. Here's a picture of the Atlantic Ocean from space, and you can see the very, very large blob of dust to the right of the screen. That's dust coming from the Sahara. That dust settles into the ocean. It's got a lot of iron in it, and it feeds the diatoms, which create oxygen. So one of 4 breaths comes from those little tiny things that I showed you. And if we didn't have the Sahara sand, we wouldn't have the oxygen that we have today. So we've got the conditions for life. We've got oxygen being formed and the first young plants being formed. When was the very first organism that had multicellular structure with a cell wall? And that's red algae. And they started to come onto the planet about 1.2 billion years ago, and they still are around today. So really, the very first multicellular plant was red algae, which exists today, and 20% of all of our genetic material is from red algae. So all the life forms that we see today is related to plants. 20% of who we are is related to forests, is related to trees, is related to daisies, sweetgrass. We're related to sweetgrass because we share the same genetic material, because we all go back to the common root. And there's the family tree of life on the planet. There's a human being at the top, but the algae is at the very bottom. So we share a lot of our genetic material with life forms that started 1.2 billion years ago. So in summary then, we have to thank the moon. We have to say miigwech to the moon, because without the moon, we would not be here today. And I want to summarize why that is. There was the big thwack. There was a glancing blow. It created iron and nickel, gave us all these chemicals that create life. The moon holds this magnetic field around us, which protects us from the ultraviolet rays of the sun. It gave us plate tectonics, which gave us the iron to provide the diatoms with the oxygen that we breathe. It gave us the tilt for the seasons. We would not have seasons if we did not have the moon holding us there, and it anchored our orbit in a stable place. And tides. People, First Nations that talk about Nokomis and tides and the giving of life and babies being born, this is all because of the moon. That constant sloshing of the water on the planet back and forth with the tides, that wetting and drying set the stage for those first tiny microbes to come together to produce life and to produce oxygen. So really, no moon, no chocolate. No moon, no us. No moon, no children. No moon, no trees. The moon is what has given this planet the criteria for life to be formed on this planet. And we know from the teachings of First Nations, the moon gives us life. Babies are born because of the cycle of the moon. Farmers plant seeds with the cycle of the moon, that 28-day cycle. we have developed the calendar. The Mayan calendar and the Aztec calendars were developed around the cycles of the moon. And art, agriculture I talked about, and language. Language is also, the root of our languages has come from people marveling at the moon. Nokomis grandmothers have always taught families. Grandmothers' role is to teach families, and so does the moon. And I want to leave you with this little poem. We are never alone. We are all wolves howling to the same moon. And the poet is Atticus. When we look at the sky and we see the moon, we might gaze at its beauty and enjoy that on a walk or whatever. But the purpose of my talk is to install in you a bit more mystery and wonder as why that moon is so important to us. It's not just a rock hanging in space. It guides so much of who and what we are and who we can be. I want to read this to you because I think it summarizes for me the story of what I'm trying to share with you about how we're all connected. As I said before, we have 20% of our genetic material is related to the plants on this planet. I'm related to sweetgrass. You are related to sweetgrass. I breathe in the soft, saturated exhalations of cedar trees and salmonberry bushes, fireweed and wood fern, marsh hawks and meadow voles, marten and harbor seal and black-tailed deer. I breathe in the same particles of air that made songs in the throats of hermit thrushes and gave voices to humpback whales, the same particles of air that lifted the wings of bald eagles and buzzed in the flight of hummingbirds, the same particles of air that brushed over the sea in storms, whirled in high mountain snows, whistled across poles, and whispered through the lush equatorial gardens. Air that has passed continually through life on Earth. I breathe it in, pass it on, share it in equal measure with billions of other living things, endlessly, infinitely. We're all connected by the air we breathe. And that air came from all those little organisms that the moon helped create. So the moon is ultimately responsible for our being on this planet today. Moonlight is reflected light. And what is that teaching for me? For me, it means that how I influence my life, how I react and engage with people, how I reflect my own energies is really very important. You know, people may not remember what you say, but they do remember how they make you feel. And so how I lead my life, I have to think about what the moon does for us. It's reflected light. Therefore, I have to reflect in my life all the goodness that I can to people and living things around me. And since I'm in the center, Wabano means new beginnings. And the moon is not full all the time. Sometimes you can't see the moon. 13 times a year, there's a new beginning. And so that is also a teaching for us, that we always have the chance to renew ourselves. I also wish to close by saying planet Earth has us on probation. There's no guarantee that we're going to be here for millions and millions of years. The Earth is a very sensitive and delicate living organism, and we have to treat it with respect. And if we don't treat it with respect, that relationship with the land might be broken. And if that relationship is broken, then perhaps we will not be here in a few million years' time. It's for our great grandchildren and their generations beyond that I leave you with a thanks and miigwech for allowing me the chance to share with you the beauty of this story of how the moon has given us life as we know it today. Miigwech, thank you.